Yeah, confirm if my screen is visible.
Yes,
Yes,
sir.
sir.
Okay, thank you. So I think okay. So the next topic is the performance matrices. I think in the last class we have studied this performance matrix. So it's a more of classification as well as regression algorithm, but more specifically this performance matrices is for classification algorithm. So I'll try to more focus on only the classification algorithms. Okay, so you know this pipeline whenever you work on any machine learning algorithms or machine learning projects. So we have a typically you have to follow these bubbles, right? These different blocks. So more specifically, if you see this few blocks, I think this data preparation, model training, and this deployment is some other parts. So this two part, the data preparation and the model training. Okay, these are the critical part of any machine learning projects. So in this pipeline, ML pipeline, so once your model is trained, right? So how you evaluate the model? So that could be captured through some of the KPIs that is being done by the model performance, or you can say the different matrices. Okay, so if you are training a classification algorithm, so you have to evaluate the training and test phase both, and how your model has performed once you have trained the model on a test data. So test data is also called unseen data. So how your model is performing on unseen environment, the data which is not fed into during the training. Okay, so this model evaluation is something which is very much important, because that will tell you the accuracy and the performance of any ML models. Okay, and this hyperparameter, I have touched a few points of this hyperparameter, because anything that you want to, let's say, if let's say your test accuracy is not good, right? And your boss wants that test accuracy must increase, so that you can reduce the type 1 and type 2 error depending on the business situation. Okay, let's say your boss wants to reduce the type 2 error, right, in a model. So how you are going to reduce that? So hyperparameter is one of the techniques to fine tune the model to bring down the type 2 error. Okay, so how you are going to fine tune the model? There are different parameters of every single classification as well as regression algorithms. So how you have to tweak that parameter so that you can bring higher accuracy into the model, right? So this is typically important, the hyperparameter this tuning. Okay, so now you know this kind of a machine learning pipeline. So once your data is labeled, you convert it into training and test set, and this training set is, you can see it's a bigger block. So 80%, maybe 85% of the data you keep in the training set, and the rest, maybe 15 to 20%, you keep it in a test set. Test set is unseen data, because your model hasn't seen this data. That is why it is called unseen to the model. Okay, so unseen data which is not given to the the model during the training phase is something which will give you the test accuracy. Okay, because ultimately you have to check how well your machine learning model is performing. Okay, and then you design this prediction model, and this gives you the accuracy part. Okay, so accuracy can be captured through the different matrices. Okay, so now we are going to study one by one. So before that, I just like to show this data set, because once you have idea about the data set, then only you can think of what kind of algorithm you can apply. Okay, so the from gender to property area, the anything which are written in the green, that is the column of this Excel sheet. This is typically the features. Okay, so there are, let's say, 8-9 features from gender to property area, anything in the green. And the loan status is your class level, or typically we call it a label. or we call it a class. So let's say there is a 1 and 0 class. They are divided into two class, 1 and 0, or two levels, 1 or 0. Okay. So let's say a person is, let's say if it's 0 is, let's say, female, married is not married, dependable or something something. So if this is the one property of a, let's say, X person, then loan status is that he will be allowed for the loan, right? So this is loan status, means he will be given the loan, and 0 is that he will not be given the loan, right? He or she. Okay. So this is a supervised data set. From this one is input and loan status is output. So both are, synchronized. For every single input you have some output. So data is supervised. Okay. If I remove this loan status, data will be unsupervised. So and that time, if you remove this column loan status, you have to apply the clustering techniques to bring some of the the pattern, the hidden pattern in the data. That is also called a knowledge discovery. You are trying to bring out some knowledge out of the unsupervised data, because data is unsupervised. You don't know what is the output. Okay. So that is why this clustering technique and different techniques are applied for bringing some of the patterns which are hidden in the data, right? So now, as I already told you, that we call it a target or class, the loan status. Okay. Either we call it a target variable, feature variable. Okay. The rest these are all called the features, and this one is a target variable. 1 is a positive class, 0 is a negative class. Okay. So whenever you see this kind of a data, this is a typical problem of classification algorithms. By looking at the target variable or class or label, if it is a binary, you can easily say you have to apply classification algorithm. So you have so many classification algorithms. For example, if you start with logistic regression, that can work for the binary classifier. Then you have a support vector machine, then you have a decision tree, then you have a random forest, then you have a k nearest neighbor, then you have a naive Bayes, then you can apply artificial neural network, then you can apply XGBoost, then you can apply there are different classifier, even you can apply linear discriminant analysis. Okay. So there are many classifier which can be applied for classification problem to predict the class label. Okay. So how you are going to measure the performance of the training as well as the test data. Okay. How your model has performed. So in that case, you have to do some kind of analysis, and these are some of the KPIs. You can say the matrices, for example, confusion matrix, type 1 and type 2 error. You try to calculate through the confusion matrix. Then you go on to check the accuracy of the model, then the recall value. Sometimes it is also called sensitivity. Okay, so people who have studied the decision science, the linear programming and all, you might have aware of this term called sensitivity. Okay, then precision, then specificity, then F1 score, then ROC curve, then PR curve. There are different curves, so it will create curve for you, and then you decide whether your curve is capturing the entire the theme of the data set or not, right? So we will see one by one. So if you see before this confusion matrix, so let's say your model, this is a traditional data you have, this is, let's say, training data. Now you are applying the test data. So your model actually has 1, but your model has predicted here 1 also. So this is a correct prediction. Let's say there are a model, let's say this instance, the model has got the 1, they have predicted 1 initially, but the prediction by ML model is 0. So this one is incorrect prediction. This one is also incorrect prediction. This one is also incorrect prediction. Okay. So let's say a person, let's say you have given to a loan, let's say, okay, you haven't given to a loan, but in your data set it is coming out that you provide loan to this person. So this is an incorrect prediction. Okay. this instance is also incorrect prediction. And now how you are going to calculate the confusion matrix. Confusion matrix is that the trade-off between the actual and predicted value. Okay, so how much your model has predicted well, and how much, you know, the type 1 and type 2 error is there. Type 1 and type 2 is nothing but the, you know, the difference between the actual and predicted value. Okay, so we have studied this one in the last class. Let me recall this one. The true negative is that your model actually has predicted negative, and also when you train the ML model, they have also predicted negative. So negative and positive is not a problem. Problem is this false negative and false positive. Okay, so false negative means actually a person didn't have a COVID. Okay, and your model has predicted he has a COVID. Okay, so a person doesn't have a COVID, has been predicted as COVID. Okay, fine, that is not a problem. But the problem is this one. A person actually has, let's say, this one has a COVID negative, let's say this one, but it is predicted as a positive. Okay, okay, let me check again. 1 minute. A person has a COVID, this one, a person has a COVID, but your model has predicted it doesn't have a COVID. So this one is a problem, this false negative. Okay, if your model is giving you more false negative, it is a problematic, because a person is really infected with COVID, and your model is telling your model is just biased. Okay, your model is not capturing the true behavior of the model. Okay, so that is why this false negative is a problematic. Okay, so how you are going to mitigate this false negative as a consultant? This could be your challenge. Okay, either you can take more fresh data, or you try just to check whether your data set has some biased field. Okay, or you try, if everything is fine, even if you have a data set and everything, so now it's problem of machine learning, which kind of a ML model you're applying. If your data set has non-linear features, okay, so for that either you will apply decision tree or random forest, because for non-linearity, to capture the non-linearity behavior in the data set, the best ML model is decision tree. Okay, and even if that is not working well for you, it's better to go for hyperparameter tuning. You have to try implementing some of the hyperparameters of, let's say, if you are using support vector machine as a classifier. Okay, whether a person has a COVID or not, in that case you have to fine tune the hyperparameter of support vector machine, so that will give you the test accuracy. Okay, so that is the optimal value. So in hyperparameter you try to fine tune the optimal value of that ML model. Okay, so you know this, in the last class I have given you the idea. Let's say this one, a passenger has, let's say, a passenger, this one is type 1 error, denying boarding to safe passenger. A person is, let's say, safe, but you are denying. But here in type 2 error, allowing a dangerous passenger to board. So this one here, type 2 error, is a problematic. It's really bad. Okay, because he is a dangerous and you are allowing to sit in the airplane. Okay, so this type 2 error here is the problematic. So in that case, how you are going to figure out and to minimize this type 2 error. Okay, and here if you see this one, the 8 and 22 is problematic. That is a misclassified case. Okay, 60 and 10 is the they are the correct classification. Okay, so these two are not the problem, but this diagonal 8 and 22 is the problematic. Let's say a person is he doesn't have, but he predicted as point, that is not a problem, but this one 8 is a problematic. Okay, so this is how you can interpret it. And as a business consultant, let's say if I have given you this confusion matrix, and if I tell you to interpret it, so you have to explain the true positive, true negative, false positive and false negative, and you have to give an idea that how you can mitigate those the false positive or false negative or type 1 and type 2 error. Okay, So that is the typical case of any business analyst. Okay, so now coming to this accuracy, as we know, there are different, this performance matrices. So we will see few of the matrices. Okay, so now we are starting with the accuracy. So how your model, if you have a ML model, the classification algorithm model trained enough, now you have to check the accuracy of the model. How you are going to check, okay, how accurate your model is and how much your model has predicted correctly. Okay, so the correct prediction is something which you just capture through this accuracy. Okay, so in the accuracy part, if you see, the accuracy in classification problem is the number of correct predictions made by the model over all kinds of predictions made. Okay, so they are just capturing the total number of correct predictions divided by all types of predictions. So in the numerator are correct predictions, true positive and true negative is there. Okay, just see. So in accuracy part, you will see true positive and true negative is the something your model has predicted correctly. So you will put it into numerator. Okay, and all other stuff, all you have to add it up. Okay, so this will give you the accuracy, how much accurate your model is. But the point is that here they are also capturing the false positive and false negative. So that is why accuracy is never the measure of one of the the best measure of any classification algorithm. It is not, because in accuracy false negative and false positive is also there. Okay, so accuracy is never a best measure of classification algorithm. So sometime people go on and they just jump on to say that if your model is accurately predicting, let's say 85%, so the model is best. No, just try to check how much false positive and false negative is there. Okay, because in denominator you have false positive and false negative terms. That is why it is making your model weak. Okay, so accuracy is something which you can see as a performance of a model. And then again, if you see this one, when to use accuracy, this is a typical the case study, you can say. So accuracy is a good measure when the target variable classes in the data are nearly balanced. For example, if let's say a churn of a customer, okay, from the banking systems, okay, let's say you have 1 lakh of a customer's record, and how many is gonna churn is let's say out of 1 lakh, let's say around 90,000 people is gonna churn, and only 10,000 people are there that they are not gonna churn. Okay, so in that case your data is imbalanced. Okay, so in that case, if you see accuracy as a model parameter, that will not be the good measure for the accuracy, because your data set must be balanced, means your classes must be balanced, means at least 50,000 or 40,000 of the two classes should be there, then it will be balanced. So 60% classes in our fruit image, let's say data are apple, and 40% are orange. A model which predicts whether a new image is apple or an orange 90% of the times correct is very good measure in this example, because 60-40 is fine. Okay, but had it been 30 and 70, it would have created a problem. So when not to use accuracy, accuracy should never be used as a measure when the target variable classes in the data are majority of the one class. As I already told you, in 1 lakh of the customers, if churning of a customer is let's say 80,000 and 20,000 people are not churning, in that case if you are using accuracy as a good measure, then you are fooling yourself. Okay, so in that case don't try to use accuracy. So for accuracy as a good measure for ML model, it's a time to bring the both classes together in a same proportion. Okay, always check whenever you get any data set, try to check whether your classes are balanced or not, whether the labels, which are the last row typically in the Excel sheet, whether they have a balanced the class or not. okay, representation of those classes. Okay, let's say here you have this cat, this tiger. So you have a different images. I think cat is there and also the tiger, and some dogs are also there. So they look like similar, you know, the figures. If you see, if you provide this image to computer systems, once you train your AI systems for computer vision, and now as a test you give this you know, the image to recognize whether you know, the tiger, or let's say cat, or let's say dog, whether how much, you know, tiger is there, dogs, or something something. Okay, so now your model is saying, let's say this one is a tiger, this one, this one, this one. So let's see how they have you know, corrected, you know, predicted well. So here if you see, this one is a tiger, this one, this one, this one, and this one. But here if you see, this is a cat, this is a cat, and this is cat. Okay, there are 3 cat. Okay, but this is a wrong prediction of the cat, this one, this one. Okay, so if you see the performance, only 37.5%. So your model has poorly worked. At least they must correctly predict 70%. Okay, so this is how accuracy sometime can you know, mislead you, and can be the faulty measure of judging any ML models. Okay, so coming to this precision, how precise your model is. Okay, so in precision, let's use the same confusion matrix, okay, as the one we used before our this cancer example. So in the last example it was a cancer example. Okay, so precision is a measure that tells us the, you know, proportion of patients that have, you know, this disease actually, and the predicted relative you know, the positive one. Okay, so here let's say in place of this you know, cancer, if you say this COVID, you can relate with. So let's say in COVID example, with 100 people, only 5 people have a COVID, and let's say our model is very bad and predicted every case as a COVID. Since we are predicting everyone as having a COVID, our denominator, okay, is 100, and the numerator has a true positive and true negative. So if you see this example, the true positive and true negative together, so out of 100% person having COVID and the model predicting his case as a COVID is a 5. So in this case we can say that precision of such model is 5. Okay, so out of 100, let's say this precision, how precise your model is, this true positive is good, because if someone has, let's say, COVID, model is predicting as a COVID. But if let's say a person doesn't have a COVID, but your model is predicting as a COVID. Okay, so this true positive and false positive. Okay, and we are just checking the strength of this true positive. Okay, so this is a called a precision. Okay, means a person has a COVID and your model has a predicted COVID. So it means how precise in detecting whether a person has a COVID or not. Or let's say a new person who are coming to your hospital, and you have those parameters captured, and now you are putting those parameters into your ML model which are already trained. And now by going through that model, once you put in that test data, your model is saying, yeah, this person has a COVID. Okay, so it means how precise, it means how precise your model is in predicting whether a person has a COVID or not. Okay, this is called a true positive. So true positive is numerator, and true positive and false positive is in the denominator. So this will give you the precision, how precise your model is. Okay, so in precision case, so if you define the precision, precision is the proportion of retrieved things that are relevant. For example, for me, detecting a person who is suffering from COVID is something that is relevant for me. Okay? So precision is that fraction of actual cats, let's say, among the cats that ML system found. Okay, let's say you are predicting in a new maze whether a new maze has a cat or not. So we are just predicting the cat. Okay, so precision is true positive divided by true positive plus false positive. Okay, so how many cats are there in this model? So let's say your model is saying this one is cat, this one is cat, this one is also cat, this one is also cat, let's say. So how much wrong prediction is there? So if you see this one, so this is the photos getting the cat level. So your tiger is also labeled as a cat, this one is also cat, this one. Okay, so I think this is also cat, this one 1 2 3 4 is cat as per my understanding. Let's see. So if you see this one, only this one and this one is cat, but this one and this one is, I think, mouse or something. Okay, so the precision is 2 by 5 here. Okay, so how much accurately your model has predicted whether the image which is given to them has cat as a one of the photograph. Okay, because our intention was to capture the cat in the photo which are shown to the computer systems. Okay, computer vision systems. So how precisely our model has worked? The precision of our model was 40% only. Okay, so now you have to train enough so that the faulty image, let's say they have the incorrect prediction. Let's say this tiger, this one is some fox or something, this one is a mouse. Okay, so they have also predicted it, but it was a wrong prediction. Okay, so how we are going to bring the change in the model so that this one should also be corrected the way we want. Okay, so how you just want to increase this precision part. So for the precision part, let's say true positive plus false positive. If you decrease this one, obviously the precision will increase. Just think of it. Okay, if the false positive is, if you are trying to reduce this false positive, let's say it is this was true positive was 3 and false positive was 2. If you are able to bring it to 1 or 0, our model will have a more precision. Okay, so in this precision case, our main aim is how to reduce this false positive. Okay, so if you see through the Python, if you want to implement, you can run it. Let's say why true, the model has predicted this, let's say person, this one is, let's say COVID, 0 is he doesn't have, 1 is COVID something. So your model has this prediction, but once you have trained the model and the test set, now you check, your model is saying no, he doesn't have a COVID and something. So how much accurately they have predicted. So this will give you the precision score. So precision score is very low. Okay, so this is how you can implement it in a Python. Okay, this is just a class level, means a person has a COVID or not. 1 is a COVID and 0 is he doesn't have a COVID. Okay, so this is just an implementation. You can implement it, and now that the important the case is that when to use this precision, because as I already told you, in case of accuracy, when to use accuracy, if your data set has a balanced the class levels, in that case you try using this accuracy, because in that case it will not be biased. If your model has a more number of one classes or one labels, so it is gonna discriminate. Once your model is developed, they are going to discriminate. So in the last class, I think I have given you some lectures on biasness of the data. Once your AI system is developed, let's say it was in the resume, I think in the LinkedIn, so female was they are not being selected because the majority of the the data set in the training data set, they used to contain the the male, whatever male, their representation was more in the training data set. So whenever a female used to come as a test, she used to get refused by the LinkedIn for the new job. Okay, so that is why that was the biasness because the class label containing the male has a more numbers. Okay, but the female representation was less. So whenever you're designing any AI systems, it's important to bring the both genders. If you have a two gender case, so you have to bring the fair amount of both genders and their representation, the fair representation of both genders in the training data set. So once your AI systems are developed, they are not gonna discriminate based on gender. The way we people discriminate, the same discrimination can be cropping into AI systems. Okay. So now how to use and sorry when to use this precision. So precision is a valid choice of evolution when we want to be very sure of our prediction. So if you want to be more sure of your prediction, so just go on to check this precision matrices. You try increasing the precision matrix, try reducing the false positive. Okay. Now there comes one other matrix, that is a recall. So recall is sensitivity, also known as sensitivity. It's a ratio of true positive to all positives in your data set, and it measures the model's ability to detect positive samples. So this recall equal to true positive divided by true positive plus false negative. Okay, so if you just want to detect the positive samples in the data set, whether a person is infected with COVID or not. Okay, so in that case, you just try to see that how many peoples are there who are really the COVID positive. So our main intention in this recall is to detect the positive samples. Okay, so same methods you will apply recall. Okay, so recall is the proportion of relevant things that are retrieved. So recall is the proportion of cats that ML systems found correctly even all the cats hiding in the image. Okay, so how many cats are there in the image? Okay, let's say your model has predicted these three as a cat, among the images this one, and this one. So how many images they correctly predict? This 2 1. Okay, so this will give you the recall 2 by 4, the 50%. At least your model has performed well. Okay, recall is 50% at least out of 4. They have able to recognize 2. Okay, so recall can be this the recall matrix can be captured through the Python programming. Just you have to give this function recall, this recall score. So recall score will check the true and predicted values. They will try to check how much difference it is created. So recall is 0.2 for this case. It's too low. Okay, so when to use recall? Recall is a valid choice when you want to capture as many positive as possible. So you just want to see how many positive predictions was made by the ML systems. So in that case, you will see this recall value. So every single matrix, it's not only you go and to check the accuracy, you also check precision, recall. Okay, these are also important measures. So those who are trained in this AI development, they check every single these matrices, because every single matrices gives you an idea, the clue. Okay, and which all matrices are important for your business. If it is a medical, then also you will check this precision and recall, because the precision in this medical industry is very much important. Had it been in marketing or other industry, you want to check the only accuracy of the model. Okay, then that it comes an F1 score. So F1 score means that you have a low false positive and low false negative. So you are correctly identifying the real threats and you are not disturbed by the false alarms. F1 score is considered perfect when it's 1, while the model is totally failure when it is 0. It is a single matrix that combines both precision and recall. The higher the F1 score, better is the performance of our model. The range of F1 score will lie between 0 and 1. Okay. This matrix only favors classifier that have similar precision and recall. So F1 score is typically twice of precision into recall divided by precision plus recall. So It is the single F1 matrix that captures both this precision and recall value. Okay, and the value of this precision matrix, this F1 score, will lie between 0 and 1. It is not gonna go beyond 1. Okay, so F1 score, this is just, you can implement it through Python. Okay, so F1 score, the value of F1 score, as I already told you, should be more. At least it should have more than 50-60%, so that the precision and recall can be captured. Okay, so when you want to use this F1 score, so when you have a model with both good precision and recall, so good coverage of actual positives and actual negatives. So precision is gonna give you the idea of how many the correct predictions was made. So maybe it is a positive class or negative class. So how many the instances it was captured through, let's say if a person is infected with COVID, so whether the model has the capture whether you are positive, the COVID positive or not. Okay, and if you are not, so model has predicted whether you have the COVID or not. So this one, the actual positive and actual negative, they are both captured through this F1 score. So this region of curve, this receiver operating characteristics, so area under curve, this AUC is area under curve. So our ROC curve is termed as receiver operating characteristics, and it's simply a graph. So if you plot it out in Python, maybe in the R or some other tools, you will see there are some graphs touching to 1, and that shows basically performance of a classification model. So ROC curves plots two parameter, TPR, true positive rate, and false positive rate. So it's a graph between true positive rate and false positive rate, between X and Y. So this is a region of, sometimes it is also called region of curve or area under curve. Okay, so this is how you implement it through Python. So if you see the threshold value, whether you want to keep a threshold value as a 50%, and the class level, let's say class level is 2, a person is infected with COVID and not COVID. So this one is a class levels. So you try to bring out the the false positive rate and false negative rate. Okay, so it gives you the idea. Okay, so this when you plot it out, the graph will be like this. Okay, so when you are going to use this AUC curve or ROC curve, it is used for binary classification, obviously, and it's a hybrid matrix used for unbalanced class. So let's say if you have let's say 80-20% of a class labels in your data set, in that case you just see this ROC curve. Okay, so that is for the binary classification problem, and ROC curve can be also used for multi-class classification. Let's say if your data set has 3 class, positive, negative, and neutral, in that case you can also take help of this ROC curve. Then area under curve. Area under curve is they are just used for summarizing a graph by using a single number. Area under curve scores are used to compare different models but can be impacted by the imbalanced data. So let's say if your data is imbalanced, so in that case don't take help of this area under curve. Okay, and let's say you are training 5 different models, so it's very important to also compare the area under curve. So area under curve will also lie between 0 and 1. They cannot go beyond 0 and above 1. So it will give you a curve, and different ML model will give you different curves depending on the training data set. The higher the AUC score, better is the model. So you just take and go for a training where you just your aim is to have a more the AUC score. So once your model has, let's say if you have 4 or 5 models, if a model has a higher AUC numbers, so in that case that model will be much better one. Okay, so this is just implementation of AUC. So generally used, when you typically use this AUC, when there is a clear distribution of classes in the given data set. If your data has a fair representation of the classes, let's say COVID positive or COVID negative, that is a fair representation. Out of 100, let's say 60-40 ratio is there, or even the 45 or 55, something like that. So that is obviously the clear distribution of the classes. Okay, you should use it when you are equally about the positive and negative, obviously in your data set, if you have an equal representation of positive and negative classes, and avoid using when the obviously the data set is imbalanced. So in that case, don't use it. Okay, that is for imbalanced data set. So if your data set is typically imbalanced, try not to use it, because imbalanced data set will give you the faulty result. So that can mislead you. Okay, because obviously the if there is the more number of one classes are there, so majority of the times once your unseen data is given to the model, there is high chance that they are going to discriminate it. They will give you the same result. Okay, so there is something called cross entropy. Cross entropy is also called log loss. So if you are trained any, let's say, text mining kind of ML systems, so they give you this log loss and the performance by comparing the actual class levels and the predicted probabilities. The comparison is quantified using this cross entropy. Cross entropy quantifies the comparison of two probability distributions. In supervised task, you have a target variable that we are trying to predict. So the actual distribution of the target variable and our predictions are compared using the cross entropy. The result is the cross entropy loss, also known as the log loss. So log loss or cross entropy, if you see this one, they are just obviously the comparison of the predicted class. Okay, so log loss is also will give you some kind of a score, the probability score. Let's say if you are getting log loss as a 40%, so in that case your model has the probability of predicting that class is only 40%. So you have just a confidence of 40%. Your model has a strength of only 40%. If you have a log loss of or probability of 80%, okay, in that case your model has a much better strength in predicting the class level. So that is the quantifiable terms of the cross entropy. Okay, so cross entropy, you can just check this one here. If you see, the log loss is 0.17. so typically it is just a strength, so it's a very the weak strength, you can say, the 0.17, that is 17%. Okay, so it's not a good idea. So log loss is the most important classification matrix based on probabilities. Okay, it's hard to interpret raw log loss values, but the log loss is still a good matrix for comparing model. Let's say if you are training 5 models and now you have this log loss matrix KPI with you. So now you're just trying to compare it with whether you have which model is giving you this better log loss values. So for any given problem, a lower log loss values means better predictions. So here in this case, here in this case, 1 minute, I think, let me just correct myself. Here in this case, this log loss, if you put e to the power 0.17, the value will be much higher. Okay, sorry. So in that case, lower log loss means your model is predicting well. So here e, I was just missing the e value, e to the power 0.1738 or e to the power, let's say, 0.80. If you see their value, you will see the contrast in the the value. So whenever you get a low log loss, you have to put e to the power something, so you will get a higher value. So that is your probability of predicting that class level. Okay, so lower log loss is a good for a model because they have a higher predictability. Okay, for predicting the class level, whether a person is infected with COVID or not. Okay, so that is something which is very much important. And this the cross entropy and log loss. So when you train any this one text mining, or let's say natural language processing case, if let's say you have a case of text classification, okay, or let's say sentiment analysis, in that case also this cross entropy will help you out in predicting the single instances, whether a single instances have predicted well or not. Okay, so this is something which you have to take care of whenever you are designing any ML systems, and which is based on classification algorithm. In that case, you have to check these all, matrices for the accuracy and performance of the model. Okay. So this is all from my side. If you have any questions, feel free to ask. So do you have any questions to ask?